All right, welcome back. And so the purpose of this video is just to cover the other half of inference, which is confidence intervals. So we've done the hypothesis test for a slope in a regression model, and now we're going to talk about constructing a confidence interval for that slope. And so we're kind of picking up in our note packet on page 13 with this example. So if you're not coming straight from the last video, remember we had this example where our response variable was course score, our explanatory or predictor was attractiveness, and now we want a confidence interval for the slope of that relationship. And so the first question here is why is our confidence interval for this beta 1 and not for this little b1? So take a second to think about that, and you can go ahead and pause the video for a few seconds. All right, and so we've kind of talked about this issue before, and our confidence intervals for the beta one, because we already know what B1 is. It's 0.06664, so we don't need a confidence interval for that. We know it's exactly that number. We don't know the true slope. So in other words, if we were to collect data on millions and millions and millions and millions of courses, and then we plotted those millions and millions of points, the slope of that would be beta 1, this idea of like there being this true slope. And so when we build our confidence interval for beta 1, we're going to end up using our same kind of general formula that we used for our other confidence intervals, where we're going to take our point estimate, we're going to add and subtract a critical value times a standard error. And so in this setting, our point estimate is the estimate for the slope. Our critical value is again some t star value with certain degrees of freedom. And our standard error, we said in the last video, had like that super complicated formula. Let me see. So that we're not going to calculate, and so we're just grabbing the standard error for the slope from our table of output. So the only thing missing that we don't have from that table of output is that t star value. And so in this example, we're going to suppose that we want a 99% confidence interval. We could go ahead and grab that t star value with 461 degrees of freedom from StatKey. And so if you go ahead and do that, you should get a 2.5865. A word of warning is that it's a little bit confusing that the t star is not this t stat value in the table. That was our t stat to test the hypothesis that the slope was different than 0. So the confidence interval t star value has to get obtained through some technology. In our case, we're using StatKey. And then from there, it's just the easy part. So now that we have the formula written out, we already have all of the pieces. And so if you calculate that out, you should get this interval. Okay. And so we then just want to take a second to interpret this interval. And so our interpretation is going to sound super similar to our slope interpretation. So I'm going to start by leaving a little bit of space. And I'm going to start by just writing out what our slope interpretation was. So we had already covered this for a 1-point increase in attractiveness. We expect the average course score. And then when we interpreted the slope, we just said we expect that average course score to be 0.06664. Now we're going to change it a little bit And instead of giving it a single, or instead of giving the reader a single number, we're going to say that it's between the bounds of our confidence interval. So we expect the average course score to increase between 0.0245 points and 0.10877 points. All right, so that's change number one, is that instead of giving like a single increase of 0.06664, we're saying it's going to increase between this range. The other part that we have to add is we have to state how confident we are. And so in this case, we have to state we are 99% confident that for a 1-point increase in attractiveness, the average course score is expected to increase between these two numbers. Okay, and so that kind of wraps up our confidence interval. There's kind of a note here that we could repeat everything we just did for a hypothesis test that the intercept is equal to 0 and a confidence interval for the intercept. The only difference would be, instead of using the numbers in the second row that corresponded to our slope, we'd use the numbers in the first row that correspond to the intercept. This is a much less common goal, so we're not going to focus on it quite as much, but we can just make a note that we can also do a confidence interval for the intercept. All right, and the second kind of thing here is that we made a note earlier that we would come back to this independence assumption and that the assumption might not be satisfied. So in this case, our data set actually contains like multiple courses from the same professor. And so there's like 463 courses, but there might only be like 300 professors or whatever, because each professor teaches multiple courses. So take a second to pause this video and think about why this might be a problem for our independence assumption. Okay, and so this might be a problem because each observation in the data set, so remember each observation is a course, it's not giving us completely new information anymore. And so why might this not be the case? Well, just because knowing an eval score from one course of a certain professor that just tells us something about the other courses of that professor. So it tells us something about the scores of the other courses from that professor. Okay, so how could we deal with this issue? Well, the simplest thing to do that isn't really necessarily the best is to just sample a single course from each professor. That kind of gets rid of that problem, but that throws away a lot of potentially useful data from the other courses that the professor taught. And so actually dealing with this issue is kind of beyond the, I don't know how you want to word it, beyond the scope of this class or whatever. So we don't really talk about how to deal with non-independence. But it's still something that we want to make a note of. Okay, and so in the next video, we will start by talking about including categorical predictors in our regression model instead of only using quantitative predictors. And the time's up, so